Welcome to AD Mathematics, and in this video we are going to look at conjugate cells. Now notice in the previous video we talked about multiplication of cells, right? So let's move on with that, and I would like us to take an example. Let's say we have 2 minus root of 3 multiplying 2 plus root of 3. Now per the rule, what is the rule saying? We take this one, this particular number, we multiply by the whole of this, and then we take this particular number, multiply by the whole of this. Okay, so let's do that. So we have 2 multiplied by 2 plus root of 3, and then minus root 3 multiplied by the whole of this, 2 plus root of 3. Okay, what do we get? 2 times 2 is 4, plus 2 times this one is 2 root 3 minus, what is root of 3? Minus root of 3 times 2 is minus 2 root 3. And then root of 3 times root of 3 itself is 3, right? So there is minus here, it affects it. So it's like minus 1 time, so we get negative 3. Okay, now you will see that 2 root 3, whatever number that it will give you when you punch it on your calculator, it is the same number that you are going to get. So if, let's say, if 2 root 3 is 4.91 blah 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 blah, here too you get 4.91 blah 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 blah. So when you subtract, you are going to get 0. If you want to go through the long process too, you are allowed. Somebody will say, I will factorize negative 3 out, and then I have 2 minus 2. What is 2 minus 2? 0. So we have root of 3 times 0, which is 0. So here, this is going to cancel this. So what do we have? We have 4 minus 3, which is going to give us 1. So this, the answer to this question, we had what? 1. Now let's take our next example. Let me write it here. Example 2. Let's say we have 16. No, 16 is quite a huge number. I want a simple example. Let's say we have 4 plus root of 3 multiplying 4 minus root of 3. What do we get? We have 4. So we take this, we multiply by the whole of this, 4 minus root of 3. And then we come and take this one, plus root of 3, multiplying the whole of this, 4 minus root of 3. Okay, so 4 times 4 is what? 16. And then 4 times negative root of 3. Per the rules, we have minus 4 root 3. Okay. If here had been negative, square root. So let's say, I think it's one of the properties we've not used. Square root of 4 times square root of 3. Notice it is square root of 4 times 3, giving you square root of 12. Yes. So let's move on. That was just by the way, don't be confused. So 4 times this is this. So we are done with this expansion. We go here. Root of 3 times 4 is the same thing, plus 4 root of 3 minus, what is 3 times square root of 3 times square root of 3? You get 3, right? Okay. Notice here too, negative 4 root 3 plus 4 root 3, they are going to give you 0. It's more like you're having x minus x. What is x minus x? 0 in mathematics. Okay, that's good. That's good. So this is going to cancel this. We have 16 minus 3, giving us 13. Now, can't you see something strange is happening? You see, in the previous example that we did in the previous video, we saw that the example that we had, they were all in one way or the other. We have a set in that. So here had 3 root 3 minus 5, blah 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 blah. But here there's a special case. You see, from these two examples, whatever we did, it ended up giving us a rational number. Now, I would like you to think about it. What is happening? And it turns out that, okay, so let me take the last example for you too. So let's say it turns out that when you have this set here, we were having 2 minus root of 3, right? And then we multiply by 2 plus root of 3. Notice this 2 is the same 2 here. This root of 3 is the same root of 3 here, but the signs changed, right? So here it was negative. When it came here, it became positive. The same happened to the example 2. Here's example 2. Here we have 4, here too we have 4, here we have root of 3, here we have root of 3, but then the sign is the only thing we change, right? So now the rule is saying, or we have observed that, let's say I have a surd in the form, sorry, root of a plus root of b, multiplying another surd in the form root of a minus root of b. Notice it's the same thing here. A, B, just the plus and minus, right? Now let's expand this expression. So we can bring the negative a out, and then we multiply by the whole of this, root of a minus root of b. The same thing, we can bring the b out, root of b out, and then multiply by root of a minus root of b. Now, what is square root of a times square root of a? Per the rules, we say we have a. Okay, because square root of a times square root of a is equal to square root of a squared. And square root of a squared, you can see this square will cancel this, giving us a. But when we talk about indices, if God willing and we are able to talk about indices, I will prove this one to you. So here we have a. What is square root of a times square root of b? We have minus, because of this minus, square root of ab, meaning a times b, plus, what is square root of b times square root of a? The same thing, plus square root of ab. What is square root of b times square root of b? We have minus b. We know that this will cancel this, right? So we have a minus b. Okay, so in general, what can we conclude? We can say that a surd in this form, anytime you multiply, you are going to get two rational numbers. Please hope you are all getting it. Yes, I believe so. So now we call, when you take this set, we say the conjugate of this set is this particular number. And likewise, when you take this set, we say its conjugate is this one. Why? Because when you multiply a set by its conjugate, the final result is that you transform the set, and then it changes from irrational number to what? A rational number, or it changes from its said nature to a rational number. That's what we call conjugate of a set. I really believe you enjoyed. In the next video, we'll talk about the relevance of using conjugate of sets. See you in the next video. Please don't forget to share the video, like the video, and subscribe to AD Mathematics for more content. Bye bye.